Hey Algebra 2 students, this is Mrs. Tran-Bloom. I have the honors of recording 4.1 notes, okay? So it said simplifying rational expressions, and we're starting out with the background, and it says let's review some simpler rational expressions. So to simplify fractions, as you guys already remember, we reduce by dividing by a common factor. So 36 divided by 64. Oh, I wrote the 2 early. But guys, if you guys can't find a larger factor that they have in common, then just start with a 2 if both numbers are even. So if I divide the top by 2, I would have 18. And if I divide by 64, I would have 32. Well, they're still even. Then keep dividing by 2 if you don't know. Now, if you do know, then you can go straight up and divide by the larger factor if you do know what it is. So I'm going to keep with the 2. So 18 divided by 2 is now 9. 32 divided by 2 is now 16. Now this is as low as you can go because 9 and 16, 9 is 3 times 3, that's the 2 factors. 16 we have 4 times 4, they don't have any factor in common. So now 9 over 16 is the simplest, so we can go with reducing fraction on that one. B. 3x to the 5th divided by 9 times x times y. Now, as you can see, I can simply reduce the 3 and the 9, and so that will give us 1 on the top and then 3 in the bottom. But what do we do with the variables? So currently, I'm going to leave the variables as is. We have x to the 5th, and the bottom we have 3xy, I'm sorry. Well, we have x's, okay, on the top, and then we have 1 x on the bottom. So there are 5 x's on the top. So if you must write it out, just like this, there are 5 on the top, and then we have 1 on the bottom. We can reduce the x on the top and x on the bottom. Any one of them will do. So now on the top, we have x to the 4th, and the bottom, we have 3 times y. And that would be our final simplest form. I'm going to make my pen not as bold here, okay? I'm moving on to C. Now, what happens when you have power to the power? So the y right here, I know you don't see any exponent, but if you don't see any, it's always a 1. So we have x to the 4th times y to the 1st. Both of those are being raised to the power of 3. So power to the power, you would definitely multiply the powers. So x to the 4 times 3 times y to the power of 1 times 3 all over 6 times y to the 7th power. Now on the top, 4 times 3, that's x to the 12th, and y to the 3rd all over 6 times y to the 7th. Similarly to example B, we have 12 x's on the top, okay? So if you're going to sit here and write it out, you have to write x 12 times. But sometimes that's just too long. What if we have x to the 422 power, right? That's just too much to write out the x's. So when we are dividing, we are actually subtracting the exponents. So we don't have any x's to reduce. I'm going to keep x to the 12th. But as you can see, we have 3 x's on the top and 7 x's on the bottom. So I'm just going to write this down this time, 2, 4, 5, 6, and 7. So technically, students, we can reduce those. So that means there are 4 x's on the denominator. Now, we know the answer is x to the 12 divided by 6 times x to the, 6 times y to the 4th. If I said x, I meant y. Now, so what happens if you want to do it algebraically? Well, oh, whoa, that is super thick on the purple. So let's go and adjust that. Okay, so algebraically, we're going to go, okay, well, there's no denominator with x, so we will leave x to the 12 by itself. The 6 can't be reduced because we only have a factor of 1 on the numerator. Now, when we are subtracting, students, we're going to go y. The top has a power of 3 on the y. Then we would subtract 7, okay? So now this is written as x to the 12, y to the negative 4 all over 6. But we can't have negative exponents on the top or the bottom. So because currently y has a negative 4 on the top, we would move it to the bottom to make that positive. So either way, you can go either route, okay? Let's do letter D. All right, 4 over 9 times 15 over 28. Well, guys, before you multiply, reduce it when you can. So 9 and 15, they both have factor 3 in common, so we are going to divide both by 3. So this is now 3. 15 divided by 3 is 5. Now 4 and 28, well, as you know already, 28 divided by 4 is 7. And 4 divided by 4 is 1. So here's what we have. We have 1 times 5 all over 3 times 7. This will give us 5 over 21. And box that up. Well, what do you guys do when we are dividing fraction? I hope you said that we will multiply by the reciprocal of the second fraction, okay? And again, don't forget, when you can reduce it right away so the numbers are smaller for you guys to work with. So they're both even. 22 divided by 2 is going to be 11. 30 divided by 2 is 15. So currently, we have 16 times 11 all over 15 times 5. Then from here, we can multiply horizontally. Well, 16 times 11, it's 176 all over 15 times 5, it's 75. You can leave it as the simplest improper fraction. Now, if you really want to write it as mixed, it's totally okay as well. The mixed number of this would be 2, right? 2 times 75, that's going to give us 150. So 176, subtract 150, is going to be 26 is the remainder, and then you put it over 75. Either one would be perfectly okay to use. Okay, now we have a special note here for all of us, just to remind ourselves. We cannot have a 0 in the denominator, okay? So any value that will make the denominator 0 is considered a restriction on the domain. Well, 0 in the denominator is super interesting, right? Why is it that we can't have a 0 in the denominator? Let's really try to find my decimals really quickly. Well, if I take, like, just say a simple number, let's call it 2, 3, 5, and I want to divide by a small number. Let's not call it 0 yet. Let's say 0.5. Well, I have 4. Well, what if I divide even a smaller number, 0.005? 400. That's even smaller, right? A bunch of zeros. I don't even know how many zeros I'm typing in. As you can see, currently, I can't just have zeros in the denominator. It's undefined according to decimals. But if I type in 5 again, whoa, that's 4 times 10 to the 17. You know how big that number is? So the smaller the denominator, the larger your answer is going to be. So as 2 or any number on the numerator is divided by a tiny number, the closer to 0, the bigger the answer would be. That's why it's called infinity. So that's why if I just get rid of the 5, it says undefined. So 0 cannot be in the denominator. That's why. All right. So let's start with your notes packet. I'm sorry, not start. In your notes packet, you guys have some blank lines. So can you please pause and fill this out? Steps to simplify rational expressions. Step number 1, factor the numerator, aka the top. Step number 2, factor out the denominator, aka the bottom. Step number 3, find restrictions. Set the denominator to 0 and solve. Remember, first semester, we study so much factoring. We study so much solving of all kinds of equations, right? So now we're going to use it. If you guys do not know how to factor, please make an appointment with the teachers or your teacher and try to get that resolved. Then step number 4, simplify. Cancel matching factors on top and bottom. Monomials with monomials. This is when you're canceling. Binomials with binomials. So you have a couple, you can only be canceled with another couple on the bottom. Leave 1 in the numerator if it is canceled completely. So what that means is if you don't see anything in the numerator, don't forget there's a 1 there and not a 0. All right. Let's try to see if we can work on 1 to 6. Examples 1 to 6, instruction. Simplify each rational expression. List the restrictions on the denominator. So this, again, remember, requires you guys to know how to factor and factor really well, okay? So on the numerator, it's a difference of 2 squares. So we know how to factor that. If I take a square root of x and square root of 4, and there's a minus in the middle, that means it's a difference of 2 squared. So the factors are square root of x squared would be x, square root of 4 would be 2. So those are the factors of the numerator. Now on the denominator, I'm going to try to see if I can factor by grouping. The first group, it has a 2 in common. I know that for sure. It has an x squared in common. So now we are going to be x minus 2 as the remainder after we factor out the GCF on the first group. Now the second group, and we know it has a 5 in common, then we have x minus 2 left. Well, these two are exactly the same, which is good news because that means it is factorable. So the factors are the quantity of 2x squared plus 5 times x minus 2. So that will go in the cell. And you can write it however you like. Okay. All right, y'all, let's find the restrictions, okay? Just a reminder, students, restrictions must be found before we can reduce. So just to find your restriction, we will take the denominator, which is x minus 2 times the quantity of 2x squared plus 5, and we set them equal to 0. Now, remember, the denominator technically cannot be 0. So what we are trying to do is to find what x makes it 0 so we can exclude it from our expression, okay? So take each factor and we set it equal to 0. So the first one is immediately 2. Then we take the second factor here and we will set it equal to 0. Move the 5 over, so that will give us negative 5. Divide both sides by 2. X squared equals negative 5 over 2. Well, we're taking the square root. Well, we have a negative number under the radical. This will give us imaginary answers. Well, in restrictions, we don't need to. We only need to restrict real numbers that make the denominator equal to 0. So currently, students, restriction, we only need to restrict one real number. X can never ever equals to 2. So make sure we box that up as part of our answer because it says list the restrictions. Now we can reduce. This is my favorite part because this is the part where I can cancel out a bunch of stuff. Okay, bam, bam. Well, in this case, I can only cancel out 2. All right, so let's write down the answer. It's just going to be x plus 2 divided by our denominator. Then normally I write the restriction right under my simplest fraction as well. Similarly, we will start with factoring. So go ahead and take a minute to factor out the top and the bottom. So hopefully you guys have x plus 5, this is the denominator here, and times the quantity x minus 3. Oh, I'm sorry, not x, n. On the numerator, I'm just going to go over this one time here. And again, please make an appointment with your teacher so that way you can relearn how to factor. Okay, it's so important. So if we're using the x on the top, you would have negative 18. On the bottom, you would have negative 7. Two numbers, when you guys multiply, equals negative 18, and add equals to negative 7 would be negative 9 and 2. And then rewrite it as 3n to the second, drop down the minus 6. You can pop in the 2n here and a minus 9n here. Now from here, you can factor by grouping because now you have 4 terms. You can take out a common factor, so now we have 3n plus 2. Over here, we can definitely take out a negative 3. If we take out a negative 3 from a negative 9n, that will give us a positive 3n. If we take out a negative 3 from a negative 6, that will give us positive 2n. So positive 2. So those two factors are identical. That will give me the factors. And again, the next few examples, I'm not going to work out the factoring part with you, but I will give you guys time to work that out if you need to, all right? So on the top, we would have the factors are n minus 2 and 3n plus 2. I'm sorry, this is an n minus 3 because we have this and this. So n minus 3. My apologies. So n minus 3 is here. All right. So before we cancel, we have to define restrictions, okay? Restrictions. Take the denominator, set it equals to 0. Then that means you have two restrictions, students. N can never ever be negative 5, and n can never ever be 3, because either one of those would make your denominator 0. Now, my favorite part, let's cancel. Whoop, whoop. All right, n minus 3, they're now both gone. So now we have on the numerator 3n plus 2 all over n plus 5. With restrictions, n can never ever be negative 5, comma 3. Box it up. All right, guys, on an example 3, almost home, right? On the top, we have an a, so we're divided by a squared plus 5a. So on the numerator, guys, there's not much we can do. But on the denominator, they both have a in common, so we would definitely factor it out. Now, before you go and cancel out the a, don't forget restriction, right? Restriction says, take your denominator and set your denominator equals to 0. So now a can never ever be 0. This is a plus 5 equals to 0. That means a can never ever be negative 5. Now we can cancel. Ready? On the top, I'm going to cancel out the a and the a. Now, do we go and write in the 0 on the top? Because everything's gone. So do we write it like this? No, do not write it like that, guys. Okay, that will be a big no-no. All right. Remember, if you don't see a number in front of a variable, it's really a 1. So make sure you write a 1 right there. Now, before we box it up, we also need to go back and add restriction. Okay, what is it that a can never ever be? A can never ever be negative 5, comma 0. Now you can box up this entire thing. Let's move on to number 4. X to the exponent of 2. So x squared plus 5x minus 6 all over x to the third minus 1. So what I'm going to do is I'm going to ask you to hit pause and then go and factor that out. Okay, I'm going to wait for you guys to factor that out. Now, if you're having trouble with the denominator, I'm going to give you a hint. Can you please go find your sum and difference of cubes? Sum and difference of cubes. In this case, this factoring, it's a difference of 2 cubes here. And I'm going to even give you another hint. One's a binomial, one factor is a binomial, and one is a trinomial. Go find that formula so you can get going. Okay. All right, hopefully you guys remember to factor difference of cubes, we have a minus b times the quantity of a squared plus ab plus b squared. Now that will allow me to write in the factors right away. A would be x, so x minus 1, and then it would be x squared plus 1x plus 1 squared, which is 1. Now that's just your denominator. On the top, you have a trinomial without a leading coefficient. So you should have 2 factors. We should have an x, let's see, we should have an x plus 6 times x minus 1, okay? And again, let's go find restrictions before we cancel. So let's find restrictions down here, y'all. Restrictions, okay? We're going to take each denominator and we will set it equals to 0. Now, remember, we have been studying in first semester, solving quite a bit with sum and difference of 2 cubes. Just to remind you guys, this will give you guys imaginary answer. Okay, we have, so don't even bother trying to solve for that one. If you are trying to factor sum and difference 2 cubes, the trinomial will give you imaginary solutions. So students, that means you only have to do one restriction. So take this, set it equal to 0. That means x can never ever be 1. All right. Then let's go and cancel. Bam and bam. So final answer for example 4. It's x plus 6, not minus 6. X plus 6 all over x squared plus x plus 1 with the restriction of x can never ever be 1. Ding, ding, ding. All right. Not too bad, right? We have 2 more examples to go. Now, as I'm transforming this into the bottom, I'm going to maybe give you a little joke. How about that? My joke today is, why do atheists have trouble with exponents? Why do atheists have trouble with exponents? because they don't believe in higher power. Ha ha. Get it? Higher power? This one? That's just a geeky math joke for you guys out there. All right, example 5, 25 minus x squared all over 2x minus 1. Now, guys, honestly, you can straight up factor the way this is, okay? I, though, normally rewrite it in descending order, meaning that the highest power goes first. So I have a negative x squared, and then I'm going to rewrite it as plus 25. Then on the bottom, I keep it as is. This allows me to go, okay, well, the negative is in the front. I'm going to try to factor that out. Then I'm left with x squared minus 25, which is the difference of 2 squared. Then from here, I will factor the difference 2 squared. So it's going to be x minus 5 times x plus 5. And again, the negative 1 is still in the front. The denominator, factor out the GCF, which is 2. So now you have an x minus 5. And again, if you can see it, okay, x can never, ever, ever be 5. Okay, so if you can see right away, you can just write the restriction right away. All right, bust out the cancellation. So now on the top, students, it's negative 1 times x plus 5 all over 2. And you can write the restriction in. Now, if you want to distribute that negative out, that's okay too. You can have negative x minus 5 all over 2 with, again, restrictions, right? In this case, when we have 1. Okay. Would it be okay if you can write like this, negative 1/2 times x plus 5? Yes, all of these are equivalent. Okay. Again, if you can see the restriction, go for it. Cancel it out, baby. All right, guys, example 6, let's rock and roll. So example 6, you guys have a binomial on the numerator and a monomial on the denominator. So when that's the case, we have to be able to factor if we want to see if it's reducible. On the top, we do have a GCF of 2. So let's take that out. We're left with y plus 3. And the denominator is 2y. We can write it like this if we like. That means we can now reduce the 2's. Okay. Final answer is y plus 3 all over y. Now, as you can see in the denominator, there's only a variable y. So you can see that we can just write y cannot be 0 immediately and box that up. So guys, the most common mistake I've seen over the years is students going like this. Okay, 2y, taking away 2y, so your answer is 6. That is not true. So please do not do that. Whenever you guys have a monomial and a binomial, make sure to be able to reduce. You have to be able to factor out from the binomial. All right, guys, and that's it.